can't think as people do. The machine is different.
What marvelous being! How gratifying! How gratifying!
Hello, everybody. Welcome. I'm Matthew Wright, I'm Director of Filmmakers Cinema at PFPCA. I'd like to welcome you all to the Regency Square Theatre for the Science on Screen presentation of The Man Who Knew Infinity. Tonight's presentation is made possible by a grant from the Coolidge Corner Theatre and the Alfred P. Sloan Foundation. Clap, clap. With this Science on Screen grant, Pittsburgh filmmakers and 23 other art house theaters around the country are working to enhance cinematic and scientific literacy by pairing screenings of classic cult science fiction and documentary films with lively presentations by notable experts from the world of science and technology. We really need to send out a huge thank you to the Coolidge Corner Theatre and the Alfred P. Sloan Foundation. Without their support, we would not be able to do this, and their incredible leadership is greatly appreciated. Tonight's presentation is coming from a local Pittsburgh celebrity in a way. He's a math enthusiast and evangelist. He's the national coach of the Mathematical Olympiad. He's a professor at CMU and the founder of XB.com. XB is a technological startup providing a free, personalized learning platform on every smartphone. So please welcome Dr. Po-Shen Loh.
Thanks very much. Okay, so thanks everyone for coming out to watch a movie about math and listen to more math on an evening. Something I will first say, it's an apology for those of you who I recognize in the audience, some of you who I recognize in the audience. This talk is not going to be super technical, in the sense that this is a talk where the goal is to actually communicate why we should actually care about math. But not just in why we should maybe care about math, but why you really care about math. Okay, so that we're going to hit that part. If you wanted a more technical talk, you should attend the classes down the street instead. Actually, well, there is a vacation right now, so I guess one might say that there aren't these classes to cover. But actually, instead, there is something fairly intense. Actually, the National Math Olympiad Training Camp is happening at Carnegie Mellon University right now, where there are 60 of the United States' top high school math students all learning math, and 10 more from abroad. Actually, just to comment a little bit about this to preface the whole thing, it is commented that I'm the National Math Olympiad coach. Actually, the group that trained down the street on Forbes Avenue last year went on to win the International Math Olympiad last year. The United States of America won for the first time in 21 years. So this is a rather incredible result. And also why I personally am very excited to be part of this series is because I have certain philosophies on what might be some of the most effective ways to have more people excel in math. Actually, I had certain opinions even on how that team won. Maybe I should start by a lighthearted remark, which is that actually after this team won, it was all over the newspapers because the United States of America had just won a global math competition. Actually, the first papers that it was published in were the papers in China, who were, roughly speaking, trying to figure out what happened. Because America, for whatever reason, is not usually rated the highest. So I was taking the call from the newspapers from abroad, and I decided to tell them what I really feel, which is that the win on the American team came from a combination of two American ideals: freedom to pursue happiness and freedom of information. And thank you, these are some things that I believe very strongly in. And in fact, that's the theme of some of the stuff that I'm going to talk about tonight. Because I'm not telling you that you should just do math because you should do math and it'll help you get an A. It'll help you pursue happiness. But secondly, because of freedom of information, today anyone can learn math, and that's the beauty of it. Okay, math. Why does anyone need to know math? Getting an A is not an answer. Instead, what I'll say is that, you see, humans are lucky. We have something called intuition. Intuition is something that makes it so that we don't actually have to do all the calculations. We have a good sense of what's going on. For example, when we look at a glass like this, everyone's heard, half full, half empty. How full do you think this glass is? Just to let you know how the picture was drawn, the red liquid in this conical glass fills 80% of the height. Okay, so it's going from the bottom of that cone up by 80% full on the cup. Do you think this cup is, really full, like half full, not really full? Many people have experienced a cup like this in their life, especially if they're over 21. But the others may have some idea of what we're talking about here. Any gut reactions? And I want the instinct from people who are just like, who came into this thing. Any instinct on if I see a cup like that, is this like a really full cup or like a half full cup or like a not so full cup? Full. Some people say it's full. Somebody says it's half full. What do you mean by half full? So somebody says it is half the volume full. Does anyone believe that this is half full exactly? How many people believe that this is exactly half full? I heard a lot of boos. I saw a few hands. So let me tell you how this question came about. So I was consuming a liquid that was in something roughly this shape, and at some point I decided, it seems like I've had a lot of this. And then I said, actually, I'm a mathematician. I should be able to figure out how much of it I've had. Let's think a little bit about what's going on here. And so there will be some math, okay? Let's suppose I take how many people have seen a Rubik's Cube? Rubik's Cube? Yeah, many people have seen that, right? So that has all these little cubes in it. How many cubes are on one side of that Rubik's Cube? 3? Is it okay? It's like 3 on a side. But does anyone know how many cubes are in it all together? It's like 27. It's like, 3 across, then 3 more across. It's like a tic-tac-toe board on top with 9, but it's got 3 layers of that. It's 27. The relation between 27 and 3 is that the reason it's 27 is that it's 3 on a side, but 3 on the other side, and 3 on that other side. What do you do with all those 3s? You multiply them, because that's actually what you've done. So you scale it by 3 cubed. So here I have a glass. It's not cubes, it's like a cone, but actually volumes scale the same way. So if I have a cone, like that, let's imagine this red liquid is a cone, because it's sitting inside a conical glass. If its dimension is only 0.8 of the height, its volume is 0.8 times 0.8 times 0.8 of the volume. Can people sort of believe this analogy? If I said a cube would go like from 3 to 3 times 3 times 3, this will go by 0.8 to 0.8 times 0.8 times 0.8. It turns out that if you take 0.8 cubed, some people can do it in their head if they've memorized the powers of 2. But other people, if you just pull out a calculator, you'll see that it comes out to 0.512. This is basically half full. That's shocking. And then when I realized that, I said, I'm supposed to be a mathematician. I should have known this. Of course it's half full. But so the next time you approach objects of this shape, you will have a little bit more assistance on your intuition. But actually, that was my whole point here. You see, if intuition was perfect, and our intuition, even when I was looking at this myself, the basic human intuition is that is basically full. If intuition was perfect, we wouldn't need math at all. We'd just use intuition. There's another case in society where, I guess, intuition and gut feelings are not perfect. And a great example of that is in the courtroom. This is why you have lawyers. Because if it was completely cut and dry just from looking at all the evidence, who was innocent and who was guilty, you wouldn't need lawyers. But what do lawyers do? They start to give you chains of reasoning, chains of argument. And actually, those chains are the same as the chains of mathematical deduction that one uses to understand something like this. Mathematics and law are both built on chains of deduction to take you from something which you definitely believe to then believe something which seems completely counterintuitive. That's why you need math, because it helps you with the reasoning. And in fact, sometimes I say math is actually a cross between art and law. It's not just about computation. It's about the reasoning. That's where the law part comes in. And the art is we like to think about things that I guess we think are beautiful. And I hope you'll find some of the puzzles I talk about here to be of that kind. I should say these puzzles are actually all coming from something that I'm releasing every week. It's called XP Solve, and it's actually partnering with The Man Who Knew Infinity. I'll say a little bit more about that towards the end, but that's a nice connection with the film that we're about to see. Let's see something else here. Infinity, and also Ramanujan. This movie is about Ramanujan. Ramanujan worked with things called infinite series. And I said that the title of this talk would have something to do with paradoxes or intuition. Well, here's something, 0.99999. This is maybe one of the most common things that people ask me about when I say I'm a mathematician and they have some curiosity. Is this the same as 1? It's the same as 1. Some people say yes, and some people say close enough. And this is actually an important distinction. Close enough is not the same as yes. but at the same time, I want to maybe make a little bit of clarity here. You see, what this represents is what's called an infinite series, which is actually something that Ramanujan thought much about. That's because it has those 3 dots. So in some sense, this is a sequence of 9s going towards infinity. But what in the world does that mean anyway? Actually, that's where, again, I say math is like a cross between art and law. You need to make up some rules about what does it mean when I write something down. In fact, some of the first rules are what does it mean when I write 0.9? If I just write 0.9, that means something. That means 9 divided by 10. It's 9/10. And actually, mathematically, if you write the 3 dots at the end, it's not that it's something that gets close to something. The 3 dots at the end mean what I'm looking at is going to be whatever that gets closer and closer to as I keep adding 9s. So that's actually defined to be that way, sort of like writing down a law. So then, well, how would you ever convince yourself that that's the same thing as 1? One way to do it is with these infinite series, and there are formulas that you learn in high school or middle school on how to do this. There are other ways to also approach it with intuition, because some people say, that doesn't look like 1. 1 is 1.0000. And it's hard to reconcile often that 2 ways of writing the same thing could be the same. But I'll tell you, there are actually ways that 2 ways of writing the same thing can be the same. For example, if I write VI, what does that mean? It means 6. But these are just different ways of writing it. There was a certain era in which the law said you write VI when you want to see 6. And now we say write a number 6 when you see 6. So, sorry? Correct. So he mentioned the Mayans. So there are many different systems. But a way that you could quickly make this resonate with your human intuition, and that's actually one of the things that Ramanujan was a master of, is to compare it to something else. How many people are used to thinking that that is 1/3? It's because if you, in elementary school, when you did the divisions, you might have noticed that 1 divided by 3 just kept giving you more 3s. And I guess as a kid, I thought that was a cute thing that I kept getting more 3s. And I saw you never stop. But if that's 1/3, how does that compare with the 0.99999? What did you do to the 0.33333? You just multiplied it by 3. So if it was 1/3 before, 1/3 times 3 is 1. In fact, at that point, this makes it so that if you don't believe that that's 1, you shouldn't believe that that's 1/3. So the 2 are connected. Okay. More things that are involved with infinity or numbers that are difficult to write on. This is another one of these fun puzzles about human intuition that I want to throw out. So I try to make my slides have as few words as possible because people generally fall asleep if they see lots of words on a slide. So let me explain what's going on here. That ball is the Earth. Pretend. And imagine that there was a red string, a red rope, running around the equator really tight. Okay? That'll be not anywhere close to here, especially judging from the weather we have today. But imagine you have this red rope flat against the ground all the way around the equator. Then suppose someone cuts the rope. That's why it's called cut the rope. Cuts the rope and inserts something whose length is 710 inches. Adds that, the rope gets a bit longer, 710 inches longer. And then imagine that the rope floats up above the Earth by the same amount all the way around. So you're dividing up this extra length all the way around the Earth. Does that setup make sense? Sort of like a hula hoop around the Earth. 710 inches is actually chosen on purpose. But does anyone know roughly how big 710 inches is? This is not really a calculation thing. But it's... Okay, somebody said it's a very small part out of the 24,000 odd miles that there are around the Earth. And I mean, roughly speaking, I think it's around 60 feet. It's not a big deal. I mean, we could fit that bit of rope inside this theater. So the question is, I told you it's lifting around the Earth like a hula hoop. How high does it get around the Earth? What could fit underneath? Like a piece of bacteria? or a ladybug, or a dog, or a person, or a giraffe, or like an entire house. Like how big does this get above the earth? You added a length of rope about like yay long, right, to something going all the way around the equator. And then you lift it up uniformly all the way around. Any thoughts? You might not be able to might not be able to put a toothpick under it at all. Yeah, that's actually what the human intuition says, and that was also what my human intuition said. But let's think about this a little bit more. There is a beautiful number that Ramanujan was fascinated with, and that many other people in the world, mathematicians, have been fascinated with. This number is called pi, okay? And that's where I'm going towards now. Pi, there's even something called Pi Day, where you, I guess, memorize as many digits of pi as possible and also eat nicely flavored baked goods. So the reason people are fascinated by pi is because the number never ends. It's 3.1415 something, 92. There are some people in the audience I know who know many digits of pi. I recognize them here. But pi is related to this. You see, pi is not just a number that we memorize. In mathematics, numbers have meaning. Pi is if I take any circle in the world, if I take its circumference and divide it by its diameter, that is pi. So if I went to the circumference of this microphone divided by the diameter, that would be pi. And even if I did this with an entire enormous circle, it's always the same ratio. So now let's start to think. If the diameter, or let's call it the radius is always, if you want to get the circumference, from the radius to the circumference, you multiply by roughly 2 pi. Not roughly, exactly 2 pi, okay? Because the radius is half the diameter. So what I will say by roughly, though, is 2 pi. I don't know enough digits of pi, but I'm going to say 2 pi is roughly 6. Is that okay? Pi is roughly 3, 2 pi is roughly 6. So what this is saying is that if I had a circle and I have a radius, the circle around is about 6 times that radius. If something goes by about 6 times, okay, imagine I have a radius which is like 1,000 inches, and I add 1 more inch. If the circumference is always 6 times what it was before, you go from 6,000 inches to 6,006 inches. How many inches increased? It's actually exactly 2 pi, which is roughly 6. What I'm saying is that because of the fact that the circumference and the radius are related by this 2 pi, actually, if you increase the radius by some amount, the circumference all around increases by roughly 6 times that. Let's take it backwards. I told you this was about 60 feet. If the circumference has increased by roughly 60 feet, what's that radius increase? 10 feet. 10 feet! If we take a piece of rope, which will fit in this theater, and use that to extend a rope going all the way around the 24,000 miles of the earth, and then lift it up by the same amount all around, you can lift it by 10 feet all the way around. Wow, that's neat. That's extremely interesting. And this is actually why a lot of people find, I guess, the beauty of math is that you can connect different concepts. And this is one of them. Actually, I should say there's a reason why 710 was chosen. For those of you in the audience who, I guess, have seen this sort of stuff before, I'll say that's related to the continued fraction representation of pi. Actually, this thing increases by 155 inches because of, let me put it the other way, it's like times 2. But it increases by a very nice number because pi has a nice approximation. But let's not go too far into that. But about pi and about Ramanujan, as we're preparing for this movie. So Ramanujan is a person who people said had remarkable intuition, mathematical intuition. As you can see, some of us, including myself, have rather poor mathematical intuition. But if you are able to sense what might be true, you can go much farther towards proving and discovering great results. There was another famous mathematician who will be mentioned in the film named G.H. Hardy, who was one of the eminent mathematicians at the time. He at some point was talking about how strong various mathematicians in the world were. And he considered himself, G.H. Hardy considered himself roughly 25 out of 100 on his scale of 0 to 100. He was one of the best at the time. He put another person who was also one of the best at the time at 30. And he put this Ramanujan at 100. That's an incredible statement. What did Ramanujan do? Ramanujan thought about a lot of these sorts of things. In fact, about pi, there's even a connection. Ramanujan came up with this. Okay, so I told you pi is the circumference divided by the diameter. This lets you calculate pi experimentally, but only if you could experimentally create a perfect circle, which is rather difficult. So if you ever want to know enough digits of pi, you actually need a way to relate pi to numbers. Remember I told you 1 was 0.99999. It's a way of adding up numbers to get closer and closer to 1. There are other ways to add up numbers infinitely far, but adding smaller and smaller numbers each time to get closer to other numbers. In this case, it's 1 over pi. 1 over pi is just about as good as pi. If you got 1 over pi, you take the reciprocal and you can get pi. How would you come up with this is another story. Actually, you'll see in the film, I don't want to spoil anything for the film, but Ramanujan had some incredible ways of coming up with things. But I wanted to bring this up because there are other interesting facts. Like this, I would say, is very hard to digest, how you might get pi. Here's something else that's actually less hard to digest. This thing on the bottom I've written is 1 over 1 squared, which is 1 over 1, plus, oh, this typo. It's actually 1 over 1 squared plus 1 over 2 squared plus 1 over 3 squared. Sorry about that. So this is like 1 over 1 plus 1 over 4 plus 1 over 9. If you keep adding these up, like 1 over the perfect squares, it turns out that you get pi squared over 6. Which might seem a little odd because these numbers, like 1, 1 quarter, 1 ninth, 1 16th, have nothing apparently to do with pi. But this is another example of how mathematics connects on itself. In fact, even the image indicates something. There's a way to prove this. Again, mathematics is also about proof, and you will see that theme in the film as well. We are not satisfied if we just say it looks like it gets closer and closer. We want to prove. And the way that you can connect this 1 plus 1 quarter plus 1 ninth to pi squared over 6 turns out to be related to an area of mathematics that is used to analyze waves, sound waves almost. It's called Fourier analysis. For those of you in the audience who have taken it before, you can do this as an exercise. I see some CMU grads in the audience. It's an exercise. Use Parseval's identity and take the Fourier transform of that sawtooth wave, and it works. But basically, this is a connection between areas of signal analysis and some beautiful fact that connects a very simple expression to pi. Why might you care about all of this pi stuff? I was just going off into the theory. Let me go back into something you care about, which is maybe intuition and something that will help you out the next time you have a coin. So if I flip a coin and I get a heads, do I feel lucky? How many people feel lucky if you flip a coin and get a heads? Not sort of, maybe. What if you get 2 heads in a row? Do you feel lucky? So the thing is, it's interesting, okay? If you ask a kid, usually the answer is yes, I do. If you ask an adult or someone who's taken a math class, they know that the answer is no. I do feel lucky, but I know better, and I don't. But they do inside. And why do you not feel lucky? It's because, well, if I'm flipping a coin, right, what's the chance that I get a head and then a head? It's like the first head is 1/2, the second head is 1/2. So we're talking about half times half, which is a quarter, which is exactly the same chance as if I got a head and then a tail. And that's why people who have taken a bunch of math classes say a head-head is not special because it's the same as if you got a head-tail. Both are the same chance, both are 1/4. But I'm actually going to tell you that your inner instinct was correct. You should feel lucky. There's a reason why the human feels lucky when they see 2 heads. It's because there's another question you can ask. And that's related to these coins. And I'm talking about things here which aren't actually often covered in classes, whether they be high school or college. So I'm sharing with you these intuitive jumps. You see, here's something else I can measure. Earlier I was just saying, what's the chance I got the heads? Here's another question. How long do you have to flip that coin before you see heads? That seems like a legitimate question, right? We could do that. And actually, when we were kids, that's what we experienced. As kids, we weren't thinking about the probability of getting heads. We just noticed, see how long it typically takes before you get 2 heads in a row. You could work that out. You can also work out the probability, not the probability, you can also work out typically how long does it take before you get a heads and then a tails, like in that order, in a row. It turns out that to get 2 heads in a row takes, on average, 2 more coin flips compared to the heads and tails. So I just gave something here. This is like, for those of you who are really into math, give that a go. Try to prove that. And that actually will explain to you why your intuition is telling you, I feel lucky when I see 2 heads, because it actually typically takes, the expected amount of time, that's the technical term, expected amount of time to get 2 heads is actually longer than the expected amount of time to get the heads and then the tails. But this little nuance is often not taught, and that's actually why oftentimes people say, oh, I feel lucky, but I know I shouldn't. But you should. That's what this is about. let me close with, let me go towards the closing. This is the last math piece I want to talk about. Why should you really care about mathematics and probability and even pi? There's a pi that will come into this. This person is holding a basketball. Actually, it's the NBA Finals right now, right? So how many of you have heard of shooting a free throw? I think many people know that. And how do you shoot a free throw? Roughly like this. This person is clearly shooting a free throw, right? Well, there's this other way of shooting a free throw, like this. And unfortunately, it has the name granny shot, which makes people not want to shoot that way. But there was actually a basketball player some time ago who shot his professional player, I believe, who shot all his free throws granny style. Does anyone here in the audience know who I'm talking about? Rick Barry, I heard. And does anyone know what was Rick Barry's free throw rate?
Over 90%.
It was roughly 90%, but just over. Okay, 9 out of 10 free throws shooting this way. The only downside is that it looked funny, okay? But nobody else does it. Does anyone know what is the NBA average for free throw shooting, percent-wise? I'll say it's around 75% if you look up the stats, okay? 75% compared to 90 is actually a fairly big gap. It's like 75% means that out of every 4 shots, you're going to miss one. 90% means like 10 shots and then you miss one, okay? Actually, you could use that same probability and pi and math to analyze the granny shot and show that if you use the granny shot and your chance of success before was 75%, it goes to 90% once you switch to the granny shot. It's not about being a superstar at the granny shot. If you have average 75% and you go to this style, it goes to 90. But let me even say a little bit about the math behind it, because this is easy. There's something very special about shooting this way. And of course, we're recording this so that we can convert all basketball players to shoot granny style, right? And you can say that science on screen did it. So now, there's something special about shooting a granny shot. It's called the symmetry of the human body. Okay? If I'm doing this, how symmetric am I? I would say extremely asymmetric, because I have to not block my eyes, and my hand is not symmetric the last I checked. And what that means is that when I shoot this way, I have 2 kinds of errors I can make. I can be wrong this way, left, right, and I can also be wrong on the power, which affects like my depth, right? Suppose I shoot this way. It's much harder to be wrong on the left, right. You're basically only into the power that you're making a mistake on, okay? But now let me give you a connection back to coin flipping and that analogy again. How does the chance, you see, with this, I have to get both, normal shooting, I have to get both the depth right and the left right. I've got 2 things I need to get right. With this shooting, I only need to get 1 thing right. Let's think about coin flipping. If I tell you you need to get 2 heads, that's a probability of 1/2 times 1/2. Heads and then the heads. It's 1/2 squared. If I need to get just 1 head, though, the chance is 1/2. The relationship is when I need to get 2 things right, the chance is the square of if I need to get 1 thing right. To put it backwards, if I know my chance of getting 2 things right, which is my 75% shot, to get 1 thing right is the square root of 75%, which is actually roughly 85%. That's not the 90 yet. The way you get to 90 is you use pi, and you use the fact that somehow the basketball hoop is not a square but round. And this is another fun puzzle, where if you use pi, you basically find out that from a 75% free throw rate, you'd become Steph Curry. Okay. Where does all of this connect together? Something you may have noticed at the bottom. All of these come from XPsolve, which is actually the feature that we're partnering with the film on, which is what we're about to see. The film, The Man Who Knew Infinity, was inspired to help find more interesting talent in the world. We'll soon see a wonderful story of talent, dedication, and mathematics. And to identify more talent in the world, it so happened that a Pittsburgh startup, which I lead, happened to be running this initiative to have a separate initiative to have these interesting counterintuitive math puzzles that we were releasing every week. They found out about us. We decided to work together, and in fact, there are 100 days left. I just took this shot right before coming out here. Anyone who finds these math puzzles interesting is actually able to go on and start solving these math puzzles. There are 2,160 so far that have done it, and they've solved 24,000 problems altogether. And as you experiment with these counterintuitive puzzles, we are actually trying to identify unusual talent, which is actually very interesting. There are 43 people already who have solved an enormous number of puzzles on the platform, and they are coming from all around the world. So we are about to move into this movie where we see a story of talent which came from possibly an unexpected place at the time. We are hoping to propagate the story of the movie with this spirit of Ramanujan math talent search. And you have just witnessed all of these puzzles that I've been talking about are just examples of that. So at that point, that's a nice segue into the movie. Let's learn a little bit, or a lot perhaps, about an amazing mathematician who had this amazing intuition which can overcome situations where most humans cannot see the truth, and who came from an unexpected place. It's a beautiful story. Enjoy.